Hello everyone, my name is Estefanía Jiménez. I am from the team Quantum 90 from High School 19, and this is our solution for the problem number 1, homemade food preservative. Since ancient times, people have used everyday substances to preserve our food, although the preservative used in one type of food may not be the same for others. So the objective that we have in this problem is to propose a homemade food preservative that could be used to preserve the greatest variety of food, rich in different biomolecules, and test it experimentally. But in order to do this, we must first identify the factors that lead to food spoilage, search for non-toxic substances that preserve food, and to design an experimental test that proves our hypothesis. But first, let's take into consideration that some properties of the food may change after applying the preservative, that the choice of the conservative will be considering factors that affect our desired result, and what is found theoretically must be related with the experimentation that we are going to make, and that there must be physical and chemical factors that will explain our solution. So let's start with this question. Why does food spoil? This is because the growth of microorganisms such as bacteria, yeast, or molds. And these microorganisms are living organisms and they need certain conditions to grow and develop, such as the water activity. That is the amount of water available for microbiological activity. It has to be a greater value than zero point 0.7. Then oxygen, because normally these microorganisms need oxygen to survive. Then temperature, because at a temperature of 5 Celsius degrees, their activity starts to be stopped. But higher than 63 Celsius degrees, they start to be destroyed. And the pH, because most of them have their optimals in an alkaline or neutral pH. An acidic environment will not be beneficial for them. With this, we can pass to our hypothesis, that is that taking advantages of these acidic properties of citric acid present in lemon and the antioxidant components in high sugar content of honey will preserve our food. We will make this through a syrup. This syrup is going to be made with honey, lemon juice, and a little of water just to make a better consistency. We choose honey because of its high sugar content. It is more than 80% of its composition, and these sugar molecules will adhere the water molecules to them, so they will reduce the factor of the water activity. They also have antioxidants and components with antimicrobial activity. Then we have the lemon, which in the media that it is, it will create a considerable decrease in the pH to a value harmful to microorganisms. And this is because of the citric acid. And it also has some antioxidants. Here we have a list of other antimicrobial activity that our syrup will have. Then we can pass to our experimental task. Here, it is going to be carried out in three different types of food. First, potato, which is rich in carbohydrates, then chicken meat, which is rich in proteins, and bacon, which is rich in lipids. And this is the procedure that we follow. First, we sterilize glass and airtight containers, then we cook the potatoes before preserving them. Then we followed making the syrup with a proportion of 200 milliliters of honey per 50 milliliters of water and 100 milliliters of lemon juice, and heat it until it was all integrated. Then we put the food in the jars and covered them with the syrup. And finally, we took the jars into a water bath. This is because in this method, the temperature that is reached is not higher than 85 Celsius degrees, so the content of the jars is not going to be damaged, and we will be eliminating the oxygen that remain inside the jars. We left the jar of potatoes for 15 minutes, and the jars with bacon and chicken for 45 minutes. Let's explain a little bit of the mechanism of this. I already said that the sugars are going to adhere the water molecules, and this is because in their structure they have hydroxyl groups that are able to make intermolecular interactions with these water molecules, and therefore they retain them. Then, going to the lowering of the pH, this is because of the citric acid, and here's a comparison of the pH that the honey had, and then our syrup with its value of 1.5, in which microorganisms are not favored. Then we also mention antioxidants, and these antioxidants act on the free radicals that affect food by two principal mechanisms. First, the hat, in which the antioxidant gives an hydrogen atom to the radical to stabilize it, and the second is the set, in which the antioxidant is giving just an electron to the radical for it to acquire a less reactive charge. And regarding the expulsion of the oxygen, this is because of the thermal expansion that the content of the jars is going to experiment when heating. When they expand, they will push the oxygen outwards. So let's make the analysis of the result that we obtained. After 11 days at room temperature, in appearance they looked in good condition. In smell, they had like the characteristic smell that each food has, and the consistency they remained solid. I mean, there was no big change in this property, but in taste there was a change because the tree food had a subtle but perceptible sweet taste. This is because of the honey. And then to determine the effectiveness of the procedure and the good condition of the food for it to be eaten, we made microbiological analysis. We made it at home using gelatin with a concentrated chicken broth cube as a culture medium. And we used 10-gram samples of preserved food diluted in 90 milliliters of water. And the conditions that we gave to these samples is that they were on petri dishes that were of a size of 60 for 15 millimeters of size. And then we put them on a room temperature, but we tried to it to be like a warm environment. Then after 4 days, this was the result that we obtained, that there was no sign of colonies formed. Their food was totally free of microorganisms, so it was in a perfect condition to be eaten. Although we obtained a positive result after 11 days of testing, the fact that we did not have any microorganisms in the analysis means that the food could be preserved for much longer, without being dangerous to health because there will be nothing to damage it, and it will not suffer deterioration due to oxidation either. So, the conclusion that we have is that we analyzed the main factors and reasons why food spoils, and we identified two substances that together will generate an environment that will prevent the growth of microorganisms, lemon and honey, combined with a butterbath procedure that would eliminate the oxygen in the environment. We chose three different foods rich in different biomolecules and tested our syrup experimentally, obtaining a positive result with no colony formation in the microbiological analysis and good resulting organoleptic properties. This means that our hypothesis worked and we have perfect conserved food. So this is her bibliography, and thank you for your attention.